Hey everyone, welcome back. This is one of the important video because here we are not only going to see what actually Trivy is, but we are going to see how does things are happening behind the scene. This is one of the important video. Why? Because we are going to see the internal architecture, how does scanning happens, on what factors CVSS scores are being generated, where does TV gets the data from, what is CVE, what is CVSS, all of these things we are going to cover in this video. And don't worry, I am going to make it very much beginner friendly so that even a beginner can understand what is actually happening when a Trivy scan is been done. This video we are going to do a deep dive on the architecture of Trivy. That is one of the important things. We are going to see application analyzer, we are going to see matching engine, we are going to see report formatter, we are going to see Trivy vulnerability database. Once the architecture is done, we are going to see the life cycle, how does this thing happens. We are going to understand where does Trivy database gets the data from, okay, and who is maintaining it, and on what factor CVSS score are been assigned. All of these things are clubbed in this video. So this video is literally an important video. So yeah, just wanted to tell you, just go through it, understand it. If you find any difficulty, just let me know in the comments. I will be there to help you out in it, right? So yeah, without further ado, let's get started with Trivy. Okay, so let us discuss about how does Trivy works internally. We are going to do a focused discussion on Trivy architecture because that is the main point of discussion in this video. We are going to understand how does the database flow and on what mechanism it is giving us the scoring, that is CVSS scoring. Right now you can see there is a mind map of complete thing that we are going to cover today, and this would be the complete mind map that we are going to proceed along with this video. The first and the main concept that we are going to discuss today is the architecture of Trivy. Now, Trivy contains four main components into the architecture, that is artifact analyzer, matching engine, Trivy vulnerability database, and a result formatter. Okay. Now, based on that, these things are working. And post that, we are going to understand from which sources it is getting the data from. Okay. What are GitHub developer advisories? Okay. And how does image scanning is being done, and what is the life cycle of Trivy when it scans an image. Those are all the things that we are going to cover today. So let's not rush. Let us first understand. Let us see the high level architecture, and it consists of four major components, that is artifact analyzer, a Trivy vulnerability database, matching engine, and report formatter. Here I will be taking few examples that will help you to understand what actually is the purpose of each component. Okay. Here, this visualization just gave us a clarity, an idea how does a Trivy scan works. So let us first understand. Now here we have a container image or artifact. So whenever I am talking about artifact, I am talking about Docker image. Okay. And in the coming videos, I am actually going to show you how you can generate a report, how you can resolve those vulnerabilities. All the things will be covered, right? But for now, let us first understand the architecture. Okay. So here let us consider that this blue box is a Docker image. Now what artifact analyzer does it will just open a briefcase, just like when you go to an airport, you just put your briefcase, they scan everything. In the same way, artifact analyzer is a component in Trivy architecture that actually scans your entire Docker image. It will further classify it into two packages. First is it will classify the vulnerability based on operating system level, and then it will sort it out based on the package management level. If you are using Python, then it will sort down all the libraries and dependency based and related to Python. It can be pip, it can be npm. Now based on your image, it will show you the differentiator. Now, okay, the first thing was to analyze. It analyzed the operating system, whether it is Debian, whether it is Red Hat, whether it is CentOS, and it also analyzed that, okay, what is the package? It is PIP or NPM. So that analysis is done. Now what next? The image further goes to Trivy vulnerability database, and it again does an scanning. Now what it does, it will again run a scan against the analyzed artifacts, and then it will show you what sort of vulnerability are present. Now where the data is coming from, there are multiple sources that we are going to cover in this segment, but for now just consider that it is a rule book where all the criminal records are been logged. Okay, so here it will just check what sort of vulnerability is present, what is the CVE ID. Okay, now it will further push it to matching engine. What matching engine does, basically whatever things are been identified by Trivy Vulnerability Database, it will further match it against the uh, artifact that we have generated and the artifact that we are scanning. Post that, once everything is done, it will club it to a single place and it will pass it down to report formatter, where it will generate a report for us. Now it can print a beautiful table over our console. It can generate an HTML document. It can generate an PDF. Now, based on our requirement, it will generate the report. And then finally, we are able to see the beautiful report over the console. That is the high level architecture of Trivy. Now, let us cover the first important component, that is artifact analyzer. Okay. Now, what analyzer does, basically, as I mentioned, it's just like opening a suitcase that lists down everything inside the box. What it extracts, basically, it reads the operating system. It classifies whether it is Ubuntu, whether it is Alpine, whether it is CentOS, whether it is Red Hat, and then it is extracting the packages. It detects the packages, whether which packages are we using, and also detects which dependencies we are using. Now, which manager are we using? Those all things has been analyzed by artifact analyzer. So if you want to visualize it, you can just imagine a suitcase. Now here the suitcase is a Docker image that we are talking about. Now what did this analyzer did? It basically it ran a check. It identified which operating system it is using. What sort of libraries and dependencies are there? Is there any config file present? Is there any secret present? What sort of application binaries and packages we are using? All the thing is been analyzed by artifact analyzer. I hope you got a rough idea what does artifact analyzer does. So yeah, let's move forward and understand Trivy vulnerability database. That is again an important component in Trivy architecture. Now, what is Trivy vulnerability database? So just imagine it as a police database where it logs all the details of all the criminals, where the criminal is coming from, what is the Aadhaar card ID. So just like the same way, it is a local optimized vulnerability database. It contains CVE, severity, fixed version, and it is located in cache Trivy. Okay. Now, if you want to visualize it, just take a reference of this folder. Now, when we are talking about Trivy vulnerability DB, so just imagine a folder where all the information regarding the security vulnerability has been logged here. Now, what sort of information is present? Basically, the CVE ID. Basically, it is the ID of the severity. Okay, and again, what version the issue was found and which version will fix the issue. That information is stored in Trivy vulnerability database, which is also used for knowing the threats. Okay, moving forward with the next thing. Now we talked about Trivy vulnerability database, and now we are going to talk about CVE data source. Where does Trivy get all the information from? Are they updating it manually or they are fetching it from multiple sources? So the answer is Trivy extracts the data from multiple sources. The first main important source is NVD, that is National Vulnerability Database, where all the bugs are being reported. Now, let's say you launch an application that is being used by every company. Okay, if there is any issue, so the patches actually raise an issue that this application contains an fix, and this can be mitigated with this code. Those things are logged in a national vulnerability database, and here basically they will get an ID, they will get an recognition, and everything is logged over here. What is the issue? How do we mitigate it? What would be the consequences if you deploy this? All the things are present over here. Second source of truth for vulnerability database is vendor advisories. Now it can be Ubuntu, it can be Red Hat, it can be Debian, it can be Alpine. Third would be GitHub security advisories. What is GitHub security advisories? Now here GitHub is a community of all the developers. So all the issues raised by the development team, all the open source developer are being logged in these advisories. That is being taken again as a reference point in these data sources. So it becomes easier for Trivy to check what sort of issues can be arised apart from NVD and vendor advisories. So GitHub security advisories are also one of the important source of data source when it comes to Trivy data sources. And again, the last is package ecosystem, that is npm, pip, ruby, second go. Okay. Now again, visualization. Now in the center you can see we have Trivy database, and here it is taking the sources from multiple sources. Now what sources it is taking from? Basically vendor advisories, GitHub security advisories, package manager, operating system, national vulnerability databases. So these are all the sources where Trivy database is taking the reference from, and it is storing in one single place. So whenever you are running your Trivy scan, this database is being taken as a reference where it is taking pull from all the related data sources. Now it took the data source, it analyzed the image. Now, on what basis it is doing the scoring? CVSS scoring. So, there are four level: low, medium, high, critical. Low stands between 0 to 3.9, medium start from 4 to 6.9, high stands from 7 to 8.9, and critical 9 to 10. Okay. Now, again, what factor it is considering the scoring pattern? First is a vector attack. Second is attack complexity. Third is privileges required, like what sort of privileges are required. Fourth is user interaction, whether is it a behavioral change or when a user does a specific action, and based on that it is doing the scoring. Those are the factors. And the last is impact on CIA, that is confidentiality, integrity, and availability. If you want to understand the scoring pattern, again this visual will help you. Basically low 0.1 to 3.9, it is based on attack difficulty, user interaction, confidentiality impact, integrity impact, and availability impact. So basically based on these factor it is telling the CVSS score. Now what is CVSS score? CVSS stand for common vulnerability scoring system. Okay. Now in order to understand this scoring pattern, let us take one example that will give us an idea on what basis it is giving lower, high, medium, and critical severity. So let us take a real life example. Let's say a bug is requiring someone to click. So this will fall under lower severity. Second, a remote attack that needs no login. This becomes some higher severity. Third, a bug that leaks password. Again, we are exposing password, so this will fall under high severity. And the last one, the critical one, a bug that crashes the entire server. This will fall under critical. Now, based on these examples, now you can understand on what basis these scoring are done, right? So what we did, we analyzed these data scan against Trivy Vulnerability Database. We understood how does the CVSS pattern works, on what basis it gives the numbering. Now let us go with the next component, the important component of Trivy architecture, that is matching engine. Now, what matching engine does? So basically what it does, whatever things we scan through Trivy Vulnerability Database, it will scan it through their own list. Okay, checking your item against the banned list. Now it compares the installed version versus the known vulnerability version. Let us take the very big example. You are using Python version 3.19 and the issue is found in version 3.20. So it will scan 19 and 20. So that is the actual job of matching engine. It will flag the matches if they find anything. It will assign the severity based on CVSS. Okay. Now we understand what actually CVSS is. It is a scoring pattern based on the severity, and based on the factors, it will give the severity number, and that is how it will generate an ID for us. Okay. Now matching engine, it will just match both the things and assign a CVSS score, and then it will pass it further to result formatter for us to see the output. Now, what sort of output we can expect? It can be a tabular format output, it can be a JSON output, it can be a serif output, it can be output in a template. We will be seeing the output in templates as well. I will show you how you can generate a beautiful PDF report or an HTML report when you want to run a scan against an image, right? So yeah, that was a report formatter. Now, we covered the main core concept of this video, that is the architecture of Trivy. Now, the question is where Trivy gets the data from. It is National Vulnerability Database. Second, vendor advisories, that is Ubuntu, Red Hat, Alpine. Third, GitHub advisories. And fourth is package ecosystem fits. NPM, PIP, Ruby, Go, all these provide the data. Now let us understand the life cycle of Trivy database pipeline. So behind the scene, Aqua Security maintains the backup pipeline. Aqua Security maintains the backend pipeline that builds the Trivy database. Now, how does it work? It collects the data from all these different sources. Now, when I tell all these different sources, we are talking about the different advisories it is taking reference from. NVD advisories, OS advisories, GitHub advisories, and package manager. So here, Aqua Security is the company who is taking care of maintaining this Trivy vulnerability database. Now, based on that, what is happening in the next level is it normalizes the data into single format. It removes the duplicated entries and conflicts. It compresses everything into a lightweight DB bundle. And this lightweight DB bundle is downloaded to your local client. So remember, whenever you are running 3V image followed by Ubuntu latest, it actually updates the database. So that updated database is coming from this compressed place. And because the data is already compressed and the data is pre-processed, your scanning is even faster and you are able to generate the report in very no time. So in this video, we learned about the architecture of Trivy. We learned about artifact analyzer. We learned about Trivy vulnerability database. We understood what is the function of matching engine. We learned about how and what does a report formatter does. Okay, we understood where CVE gets the data from, where how does Trivy maintains the database. So there are multiple sources: package manager, operating system, GitHub security advisories. Okay, these are multiple data sources where the Trivy is maintaining its database. And let us understand how does this scan flow once again. So once you pull the Docker image, it actually the image has been analyzed using artifact analyzer. Then again, local query is run by Trivy vulnerability database. Now that database is again maintained by Aqua Security, which fetches the data from multiple sources: advisories, package manager, OS, and NVD. And then it is further passed to matching engine, where it matches the previous version and the current version. And based on those matching pattern, it gives the CVSS score. Now, on what basis CVSS score is been given? So basically, based on the criticality of the bug and the nature of the bug, it gives us the CVSS score. Now, once everything is done, it pass on everything to report formatter and it generates a beautiful report for us. So that is how Trivy is a simple, fast, reliable vulnerability scanning tool. I hope this gave you a very good idea about how does Trivy works behind the hood. What does the architecture of Trivy looks like? Next video is again a very important video. Why? Because I am going to tell you how to perform the scanning, but also how to fix it. We are going to fix the medium, low, and critical if possible. All the things we are going to cover in the next video. So stay tuned. It will be one of the best and important video that will help you in your learning journey. So yeah, that was all, and I will see you in the next one.